Let's begin. Today's October 6th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 5, 11, 17, 19, and 21. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. Criteria card A looks at our first digit, the triangle digit, and the Turing machine will let us know whether it's an even digit or an odd digit. Criteria card B will take a look at our first 2 digits, triangle and square, and compare them. Should the value of triangle be less than square? Should they be equal? Or should the value of triangle be greater than square? Criteria card C will take a look at our 3-digit solution and will let us know how many of those digits are even. Are there no evens? Is there a single even? Perhaps 2? Maybe even all 3 are even. Criteria card D again takes a look at our first 2 digits, triangle and square, but this time it'll take the sum of them and compare it to the number 6. So should the sum of the 2 digits be less than 6? Should they be equal to 6? Or should the sum be greater than 6? And finally, criteria card E again takes a look at our 3-digit solution and will let us know a little bit about its structure, so to speak. Specifically, there are 2 cases. One where the 3-digit solution has a pair, as in the example 131, or alternatively, it has no pairs, but there are 2 cases. One where all the digits are different, as in the example 134, or all the digits are the same, as in the triple digit 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to test is criteria card A. Okay, so the Turing machine does not approve of my choice for a triangle. I did pick an odd 3, but because the Turing machine does not agree with that, it's actually letting me know that the value of triangle is in fact an even digit. So let's go ahead and type that up in our notes in section A. And that again is that triangle is an even digit. And since it is even, let's go ahead and cross out all the odds. So 1, 3, and 5. The next thing I think I'd like to test is criteria card E. Okay, so the Turing machine does approve of my proposal. Notice that in my proposal of 314, all the digits are distinct. They're all unique. So that falls under the no pairs scenario. So that's what we have. And so let's type that up in our notes in section E. And we'll say that the solution has no pairs. Now, of course, we don't know if it's going to be all different or all the same. And yeah, I don't see anything right off the bat that would indicate one or the other. So let's see, what else could we test? So we do have a single even in our proposal. So we know that we can't have no evens. We do have 1 in triangle. So if we tested criteria card C, is there a way? And I think you can't have 3 evens. Yeah, this is actually maybe perhaps interesting. You can't have 3 evens because at least one of them would be paired up. When you're limited to just a 2 and a 4 and you have 3 digits, you're going to have at least 1 duplicate. So yeah, you can't have none, you can't have 3, and so I do have one. So the choices are either one even or two evens. So let's see. Is it worth testing that? I think I'm going to test criteria card C. Okay, so it does not approve of a single even. So in fact, we do have two evens in our solution. So let's go ahead and type that up in our notes. So we'll say that the solution, actually, let's state we're going to deduce the solution, and we'll say it as, since we know that there are no pairs, the solution is 2, 4, and an odd. Okay, the reason again is we know that there are no pairs, and since we have two evens, it has to be 2 and 4, no pairs. And of course that third digit must be an odd. Okay, so that means that among square or circle, we have another even there. Okay, well, I believe that does it for this round. We did complete our 3 Turing tests. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card B comparing triangle and square, and we did not test criteria card D, where we're adding the first two digits and comparing it to the number 6. And it really does come down to those 2 cards. So, of course, in criteria card B, you're not going to have them be equal. And as in previous problems, if you have 2 evens, especially a 2 and a 4, it could be that the first 2 digits do add up to 6, and so you could have a combination of a 2 and a 4 there. But how would you pick circle? Notice that in our 5 criteria cards, we don't mention circle. So somehow circle is going to be forced into a particular value. And so if the first 2 were to add 6, we know it would be 2 and a 4, and circle would be odd. But I don't see anything in the criteria cards that would help us pick between 1, 3, and 5. So in fact, I believe that square must be the odd, and circle will be the other even. So somehow criteria card D, adding the first 2 digits, an even and an odd, will sort of force the issue for us to pick the other even in circle. So what could we be looking at? It could be, we know it can't be equal to 6 because an even and an odd will never give us an even quantity. So we know it's going to be either less than 6 or greater than 6. And you do have, many possibilities. You have, 1 and 2, or let's say 2 and 1, and 2 and 3 for less than 6. And then you have, 4 and 1 as well. And then you have 2 and 5, 4 and 3, and 4 and 5 as sums that would be greater than 6. So obviously, if we are able to figure out what triangle would be, circle would be the other even. And so at this point, I think it's pretty much a 50-50, so to speak. Hopefully, we'll be able to hedge our bets in some way. So let's see, what could we have? I mean, it really is almost any possibility. So let me go ahead and say we'll add, say, 4, 1, 2. So with 4, 1, 2, I'm basically saying that the sum of the first two digits is less than 6, and that triangle is larger. So let's go ahead and try it out. Okay, so I think the first thing we should test is criteria card. Let's see, can we deduce? I'm not sure, but let's just go ahead and test criteria card D. Okay, yes, so the sum of the first two digits is less than 6. Again, I did pick a 4 and a 1 for triangle square. That sum is 5, which is less than 6. So yes, it's true that triangle plus square must be less than 6. And so let's go ahead and type that up in D. So triangle plus square is less than 6. And does that inform us in any way? So I believe if the sum is to be less than 6, square cannot be a 5. Because if you add 5 to either the 2 or 4 in triangle, that's already going to be a sum that's greater than 6. And yeah, it's very interesting. So let's see. Yeah, I think now that we've confirmed this, can we just cross out all the evens? Well, yeah, I think, yeah, you can cross out the 2 because no duplicate, so it couldn't be 2, 2, even though that sum is less than 4. And obviously 4, 4 won't work because that's larger than 6. And 2 and 4 won't work. So yeah, let's go ahead and cross out all the evens as well. Okay. And so now let's test criteria card B. Okay, so it is not correct. Again, we're comparing triangle and square. It's not correct. Well, I chose a 4 for triangle and a 1 for square. So my triangle is larger than square, and that is incorrect. So, and we've already concluded that you can't have 2 even, so they're not equal. So I'm going to type it up as we're going to deduce that, in fact, triangle should be less than square. So let's type it up as triangle should be less than square. And let's see what that means as far as our solution. Okay, so if triangle is to be less than square, I don't think square could be 1. Yeah, because if square were 1, there wouldn't be anything smaller for triangle to be. So that means that we have 3 for square. And of course, the sum has to be less than 6. So it can't be a 4 for triangle. And so that would lead to 2, 3. But because there are no duplicates, that means that circle's forced to be a 4. So that means that our solution is 2, 3, 4. Okay, so let's type it up. And so let's actually review quickly to see if it matches. So is our first digit an even? Yes. Is it true that the first is smaller than the second? Yes. 2 is less than 3. We deduce that the solution should be 2 and 4 with an odd. Yes, we have 2, 4, and an odd. And the sum of the first 2 is less than 6. That's correct. And there are no pairs. It looks great. Let's go verify. So 2, 3, 4. Okay, fantastic. That's correct. And how do we do versus the Turing machine? Well, we did have 5 criteria cards and we did 5 tests. So whenever those match up, it's a good indication that we at least tied, if not perhaps we did even better. So we did do ACE in the first round, and E was the only correct one, and we did the remaining 2 tests in the second round. So ACE. Okay, so ACE. E was the only correct, and then we did B, which I believe was incorrect, and D was correct. And so, wow, so we actually beat it by 2 questions. Well, let's go see what happened here. Obviously, in combination in the first round of criteria cards A, C, and E, we were able to figure out that we had 2 distinct evens and an odd. So that gave us a good opportunity, like I said, to come up with a good proposal. And we just got lucky that the sum of the first 2 was less than 6. And we just made an adjustment in criteria card B. Well, what do you think? How did you solve? Did you use a different order of criteria cards? Did you discover any aha moments that you'd like to share? Add those thoughts to the comments section. If you like the video, please give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to be notified of any future videos. Well, until next time, have a great one.